Okay, today is our last review for the tests tomorrow. It's on law of sines. What else? Law of cosines. What else? Heroes. Good. Areas. Is there multiple ways to find areas of triangles? Oh, yes, there is. And if they're right triangles, there's even different ways to find areas of triangles. Um, and we've got a lot of tools now. This is not too tough if I just give you a very simple, straightforward drawing, but that's not what you're going to have. You're going to have situations, and then there's a lot of 3D involved. And so, all right, to start with, I'm going to give you just a fairly simple one. Two people are walking in different directions. We know that the angle that is formed on their paths would be 46 degrees. And one of them walks for 3 miles, and the other one walks for 4 miles. My question is, if they at that point were to be able to shine a laser from the one to the other, have you guys seen those lasers that are super powerful? I really want one, but I know that then it makes me a possible target for the police. Do you know why? Because you can get in big trouble if you shine one of those things on like a plane going overhead. Big trouble, because you can blind the pilot even if it's just temporarily. Not being able to see in the cockpit is a big deal, and so it's getting to be a real problem, because you can seriously order one of those giant lasers on Amazon for like 50 bucks, and they can, it's not like a pen light. You know, we're talking like it's like 5 times, maybe 50 times more powerful than that, and you can shine at ridiculous distances. Has anybody seen them at fireworks shows, for instance? The last time I went to a fireworks show, there was like 3 people that had them, and they were like waving them up in the sky, and then it reflects off of the puffs of smoke from the fireworks going off. It's actually kind of cool, but it's kind of kind of annoying that some kid can be down there going like this, and everybody has to watch what he's doing. You know what I mean? Yes.
I do a lot of fireworks up north,
Okay.
and a couple years ago I used lasers like the powerful ones, like fireworks from.
Are you serious? That they're that heat generating that you can light
So
things
instead of
with them?
being that thrown off to a lighter, I can just like be on my porch and light it.
Oh my gosh.
Yeah, like
Wow.
top balloons or like just
Huh. So you have one of these mega lasers.
not a mega one. It's
Well, it's hot enough to light things? Wow. Okay, one thing at a time. Yes?
Yeah, I was gonna say something like that for a school project. My brother made a sort of a lightsaber using one of the lasers.
Huh.
They try to like slice the paper and stuff, but then you can
Yeah.
actually cut like thin enough paper like tissue.
If it's burning things, I'm thinking that like serious damage could happen if you get shined in your eye.
yeah.
Yeah.
Really powerful ones you have to
Yeah.
they like send glasses.
They send glasses with the laser.
Glasses.
Wow. Yes. Uh-huh. So she could like circle constellations with her laser. Oh my gosh. Yeah, it's pretty amazing. And then there's like a plane flying overhead, and they think you're a terrorist trying to knock it down. Anyway, um, so these people, they shine a laser from the one to the other, and then the question is, how far apart are they? And my question to you is not just to answer the question, okay? Do answer the question, but I'd like you to make me a list of formulas that would work for this and formulas that would not work for this until you have more information. I mean, every formula can work if you give it enough information, but we don't have enough information to use several of our formulas. So I'd like a complete list, please, of what formulas could work on this situation and what formulas could not until we've calculated more stuff. Because I know they could all work after several calculations. Yeah. All right, so try to make a list of all your formulas and put them in either works or not, and get the answer for me. All right, so here we go. Tell me, did you have a easy setup for law of sines? Yes, you did, because you had an angle and side across from it. So this is a law of sines kind of question, so really not too tough. All right, and then the distance, just cut to the answer. What'd you get? 3.2? Raise your hand if you had 3.2. Okay, good. Then if it's 3.2, we could use heroes, because now we got all the sides, 3.2, 5, and 8. And just I'll start that one by finding the semi-perimeter. So these add together, and you make 16.2, and that's the semi-perimeter, right? No, that's the perimeter. And therefore, what is the semi-perimeter? 8.1. And then you'd use square root of 8.1 times 8.1 minus 8, which is 0.1, 8.1 minus 5, which is 3.1, and 8.1 minus 3.2. What is that? Maybe you didn't write it down. You probably put it right in your calculator, huh? 8.1 minus 3.2. 4.9. Thank you. And when you multiply them all out and take the square root, Mr. CP, what did your group get for the area? I think that was the distance. That's all right. 3.6. Raise your hand if you had 3.6. Okay, good. Okay, it's probably a rounding thing. 3.6 to 3.7 kind of sounds. It's probably a. It all depends on where you round these. Okay, so I'll go 3.65. Maybe it's somewhere in the middle. And the last thing is the other angles. So how am I supposed to find those? Law of sines, could that work? Sure, law of sines can work. If law of sines can work, it can find you angles and sides, right? Okay. SM, what did you get for the other angles in here? 153 was one of them. 16. Raise your hand if your groups had something similar except for rounding. Okay, good. Then let's move on to the next kind of challenge question. What you see in front of you is a box of Kleenex. But what's really inside there is a super weapon that we're going to smuggle on to the airliner. Should I even not make a video on this? Okay, fine. It's a beautiful pink triangle that you're hiding from your wife that you made out of porcelain. Okay, so anyway, it's inside the Kleenex box. So let's, first of all, what do you need to know? Like, can you, again, I'm going to tell you, it's the biggest triangle you could possibly put into this box. What do you need to know from me? We can't go in the box, but what do you need to know? The long length of the box. Okay, I'm going to do estimates here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inches tall. Sitting up kind of like this. My box Kleenex. Okay, it's 10 inches tall. What else do you need to know? The width, okay. It is 1, 2, 3, 4, 5 inches wide. I suppose the depth, right? 2 inches deep. And I'll tell you, if you try to find this triangle, that's not it. Because that'd be way too easy. Got to think 3D. All right, so the first thing I want you to do is actually just try to figure out with your partner where would this biggest triangle have to be in 3D? Because you can turn it kind of sideways and stuff inside the box. All right, I'm going to make a little bit better box if you make it two identical. Clone it and move it like down at an angle like this and connect the corners. Sometimes you can get a little better 3D picture going. I want to pause for a minute and see if you can figure out for me what are the dimensions of this beautiful porcelain triangle that you've constructed. And once you have the sides on it, it'll be very easy to tell me what the pointiest side would be, the angle made by the pointiest side. Just find the sides first, because the angle will be easy. Once you got a triangle, you got the sides in it, it won't be that hard. You know what? In the context of how much time we have, I don't even need the angle. Just find out the dimensions of the triangle. Length, width, all three sides. I'll pause while you figure that out. Okay, here we go. Can anybody beat the triangle that would go across the base like this and then up to this near point right there? Can anybody beat that one? I hope so, because that's not the right answer. Well, how about this? If I were going to do that one, do you get that this side along the bottom would not be hard to find? Did you find that one, anybody? You must have used that one at some point, didn't you? Okay, what'd you get? Square root of 29. Sounds believable. 25 and 4, 5 squared, 2 squared. And square root of 29. 5 point what? 39. Thank you. So that's one of our sides of our triangle. Can you give me a different spot I should connect to? Maybe I should put some letters here. A, B, C, D, E, F, G, H. Okay. Which of these do you think would be better? Yes, ma'am. E, G to A. All right. So let me see if that would be any different. It would definitely be different. Okay, I'm going to go with, I'll make that with this pink here. E to G. How about this? Is there any way to do better than from E to G? Is there anything longer than that? Okay. And then if we're going to go and make a pointy triangle, its other end has to touch either A, B, C, or D, doesn't it? Is there a longer line than from E to G? All right. I get what you're saying, but I mean, as far as this place where the triangle can touch, if it has to touch the bottom of the box, then that would be the longest line on that bottom of the box. But does it have to have its base at the bottom of the box? No. So there's other alternatives, but the suggestion here was, I think you guys said you went to A. All right. That's a possibility. All right. Does somebody have one they think would beat it? If we do that, that one's kind of simple. It's got one side is 10. I like that. The other side's 5.39. And then it wouldn't be too hard to find this last angle, would it? Because or last side. Do you get then? I have this is 5.3, and I have this is 10, and I know that that's a right angle, isn't it? And then do you get I have a side angle sandwich? Because I've got 10, and I've got 5.39, and it's a right angle, so this last side is easy to figure out, right? Well, even just because it's a right triangle, you can use Pythagorean theorem. No big deal. How would you tell if one triangle was bigger than another? Well, you could find its area, right? So this one's area, I can know this one's area really quick. Base times height divided by 2, right? So it's about 16-ish, and then divided by 2 is like 8-ish, area of about 8. Can anybody beat that with a different triangle? If you have a triangle, you should be able to know its base and its height, and you should be able to find its area pretty easy. Okay. Oh, you're right. Thank you. It's not 10 plus 5 is 15. It's 10 times 5 is 50-ish. Probably more like 53 or something. So 26-ish, 27-ish, 26.95. Anybody else get an area of 26.95 as their answer? A bunch of people did. Can anybody show us one that's bigger than that? Yes. E to B. All right, so then let's make that with a different color here. E to B, and then what? And then B to G, and then E to G. All right, well, E to G, we already know that one. That one's 5.39. Did you get that also? Okay, and then if we do this E to B thing, that seems like it has potential. It might be longer than that other one. In fact, the same. Oh, is it? Okay. Well, let's find out. If this is going E to B, then it's the diagonal on this little box, which is a 10 and a 5, and therefore it's easy to figure that out. That side right there has, it's a triangle. Man, there's so many triangles running around. So I'll make another colored triangle. Let's make it dark blue. And then to get this side right here, I'd probably use this triangle right there to figure it out. So that's 10 by 2. And so then it would be 10 squared is 100, 2 squared is 4, 104. Square root of 104 would be this side right here. It's about 10 point something, 10.1, 10.2. Okay. All right. All this exercise is meant to do is make you look at 3D stuff because you can see it's kind of complicated. The biggest one is the one that she just suggested, and I think it's the same. Again, there's multiple ways you could take the same triangle, put it in the box. So 5.39 is the base, and then this, which is at a right angle, was the square root of 104. If you take that, it's slightly bigger than 10, right? And therefore, when we take it that times that and then divide by 2, it's got to be bigger than that other one. Do you get why? Because the other one's side was 10. This one's side is 10 or 10.1-ish. So it's just slightly bigger. All right. Okay, good enough on that one. Now, let's do our pyramids of Giza. So get to Google Earth, and I want you to just type in pyramids of Giza, G-I-Z-A. Pyramids of Giza, and it'll fly you in to the pyramids. I gotcha. Go ahead. But it might take you a while, especially unless you happen to know where they are in Egypt. You might be able to even find Egypt without that much difficulty, but you guys know that there's certain areas of this Google Earth that are not as they appear to be. North Korea.
I was looking for
They-
like islands.
They interesting.
Found them already.
Why would they be blacked out?
They're not. No, but they're like the image.
Aliens.
What is?
I guarantee you that the government has come in and said, this is an area, Google, we're not going to let you put up on Google Earth because it's sensitive, too sensitive. I'm not telling you where. I'd have to kill you if I did. All right, so anyway, there's a new, of course, I'm just joking. There's a new thing that just came out the other day. Did you hear about Apple and the iPhone? It's an interesting debate about whether or not it's okay for a company to refuse the government. The government has said, help us get into the iPhone. It was the San Bernardino shooter's iPhone. And of course, surprisingly enough, you know, we don't know his 4-digit code, right? Well, after you try 10 times, your iPhone locks, and then it's in that locked state now, and they can't open it. And isn't it a little bit surprising to you guys that our U.S. government can't get into an iPhone? I thought they were better than that. I thought they had like super hacker guys who would just like, oh yeah, I can get in an iPhone. Apparently not, because they have asked for Apple to give them help in opening this iPhone because they want to see if this guy had other accomplices. I mean, wouldn't you want to know who this guy was, you know, kind of conspiring with? But it's an interesting dilemma. I'm not going to say what the right answer is, but I can tell you the argument is, government side is, you should help us open it so we can save lives. Apple's argument is, It's privacy, and we don't want to make the government be allowed to see your stuff just because they say so. But the judge, there was a judge who gave a court order, you will open that iPhone, and Apple is still refusing. So it's interesting. Yes?
They actually are arguing that they can get the software in order to open it, and that software could get out.
So you're making the case that Apple is saying that we don't want to offer a hack because then that hack could get out to more than just the police and therefore compromise everybody's security. It's an interesting argument. Yes?
Yeah, the FBI were just asking about that one phone. They wanted a complete backdoor to all linked to iOS itself, so they could look through the entire operating system, not just unlock it, but also look at all like private folders and stuff like that. So they just wanted something backdoor.
Gotcha. So if the question had been not can we open this one iPhone, I think everybody'd probably say, yeah, we know this guy did a terrible thing and we kind of want to be able to see if he's got other accomplices and whatever. But it's if there's software that could open everyone's iPhone whenever they wanted to, that might make you feel different about that. So sometimes things are more complicated than they appear on the surface, but it's an interesting legal question. All right, so my question for you is, those pyramids that you are seeing on your screen and you flew into, if I gave you the dimensions of them, would you be able to help out? Because they'd like to resurface them. Because, do you believe it or not, the pyramids have shrunk dramatically, like many, many meters. Okay, just meters. Yes, you can look it up. Many meters. It's many meters shorter than it used to be, just from erosion. And I know that bothers you, and it doesn't seem like it makes sense, but I just read it the other day, and of course, if I read it on the internet, it must be true. So they're going to resurface them. Okay, I'm making that part up because they would never want to touch these for real. But imagine for a moment that your job was that they wanted to resurface them, and therefore, I'll love to look later. And you need to therefore know the area of these big triangles, right? All right. So my question for you is, take the pyramid and its dimensions, which you don't have right now. I just want to kind of see it from the sky. And we're going to do this through Pear Deck. So everybody please, right now, get into Pear Deck. I may be done with the video at this point for this one last problem, but we'll see if it works. Pause this. All right, so this is an example of how I could tweak a problem to make it more complicated. I'm not actually giving you the distance, but you got to figure it out. All right, that's good enough. Have a great day. Ask.